All right, so now we've seen our processes are completely isolated from each other and are also isolated from the kernel and from the hardware. Completely isolated from the kernel? Well, not really, because we've seen before that the kernel can initiate a communication with the process in order to indicate something special has happened. This was done with signals. For example, if the kernel wanted to stop a process, it could send a signal and tell the process to stop what you're doing, you're going to stop operating. But for now, this was only at the request of the kernel. How would a process initiate a communication with the kernel and ultimately with the hardware? For example, if you want to write something on the disk, or if you want to access the internet, you're going to need to use some hardware, whether that is the hard drive itself, communication such as Ethernet card, or Wi-Fi. This is done using what's called system calls. System calls are functions, which are special kind of functions because they actually drop you into kernel code, and the kernel is going to execute the system call for you. So an example of system calls which are used for input-output operation would be the read, write, open or close system calls. And you will notice in the documentation, you will see 2 in parentheses after this function. This means they are at the second chapter of the documentation and are just system calls. So system calls is initiated by the process, but it also means there will be a communication between the kernel and the process. Process will ask the kernel to write something on the disk, and the kernel will answer back, yes, I actually have written something on the disk. Or it could answer with an error, like you don't have permission to write something on the disk.